Hey guys, welcome to today's session. Today we're gonna talk about multiplication rule. Again, like always, please go to Google Classroom, pull up the worksheet so you can see what I'm talking about and also take notes at the same time. Let me show you my screen. So first of all, I want to talk about what is standard deck of cards. In a lot of probability problem, you will say, okay, draw a card from a standard deck of card. What does that mean? So standard deck of card is it's just like the poker we play like in the real life, but without like two special cards. In a standard deck of cards, there are totally 52 cards, and they have four suits: club, spade, heart, and diamond. Club and spade are black cards, and in each of them, you will have ace. In some country, we also count it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, and king. And also the same thing with spade, and also heart and diamond, we count those as red card. They have the same thing in those suits. So in each suit, we have 13 cards, and they are totally 4 suits. 4 times 13, we have 52 cards in a deck. So in the future, if you see somewhere saying a standard deck of cards, you will know what they are talking about. And if you can scroll down, let's go to example 1. In example 1, we need to not only learn the multiplication rule, also I need to remind you about what is the basic formula of probability. So let me read the question for you. A card is randomly chosen from a standard deck of playing cards and placed back into the deck. What does that mean? Means you're gonna draw a card and you're gonna look at what that is, and then you're gonna put it back and you're gonna shuffle and you're gonna draw again. Then a second card is randomly selected. Find the probability that the first card is the ace and the second card is the king. So over here, as you can see, we have two events here. Event 1 is the first card is the ace. So event A, we said the first card is the ace. That's how you define event A. Event B is the second part. The second card is the king. Event B, the second card is the king. So first definition we want to introduce here is independent. I ask you, is event A and event B are independent? So what is independent? According to the definition, independent is when two events does not affect each other. For example, if I say event A is my name is Tong Xie, and event B is your name is whatever. Let's use a random name. Your name is Jaden. Okay, so my name will not affect your name. Like if you are not relatives or anything. So my name event A and your name event B will be independent event. Or for example, if my event A is it will rain tomorrow, and my event B is saying people in China eat rice. So those two events, they does not related to each other at all neither. So event A and event B also independent. So what is dependent event? Dependent event is saying two events, they are they can influence each other. So for example, event A is I sleep at 2 o'clock in the morning. And event B is I am very tired the next day. Do you see there's a connection between those two events? If I sleep 2 o'clock in the morning, then I most likely will be tired next day. So those two events are dependent events. Or for example, if we want to use an example, we use like a lot of time in probability. An independent event will be if I roll a dice. The first time I roll a 1, and I roll again. The second time I roll a 6. Those two events are independent events because every time you roll, it does not influence each other. And a dependent event will looks like if I have a deck of cards, I draw a card, and it looks like it is an ace. I should have a real card, but I don't. So it's an ace, and I put the ace out. I draw again. Do you feel like the first time I draw ace is more likely because there are 4 ace in a deck of card, but second time I draw they only have 3 ace in the deck of card because the first time I draw 1 ace out. So those 2 events are dependent events, and in today's lesson we will look at a lot more example like that. So let's go back to our worksheet. So they ask you, is event A and event B independent? So over here we will say it is independent. Why is that? You will ask me earlier, did you say, okay, draw card is not independent? It's not true, because they said you're gonna draw a card and you're gonna place back into the deck, which means in the first time how many aces you draw, it doesn't matter, because the second time it's the exactly same deck of card you are drawing. So those 2 events are independent, okay, because they do not affect each other. Okay, so probability of event A is what? Okay, so we said the probability is equals to a fraction. On the top will be your desired outcome. Your desired outcome for A is first card is an ace. So you're gonna go back to your deck of cards and see how many ace you have. You have 1, 2, 3, 4 ace. So on the top will be 4. On the bottom is all the possible outcomes you can have. So all the possible outcomes, you can have any card in this deck. In all the possible deck you have will have 52 cards. You will have 52 over here. Oops. Okay, 52 on the bottom. Again, on the top is what do you want to happen. On the bottom is what possible chance it happened. If you reduce it, divided by 13 on the top and bottom, you will have 1 over 4. Okay, so this is your answer, 1 over 4. And then we look at probability B. Probability of B is, they said the second card is a king. The second card is a king. It is not influenced by the first card. So over here we will be doing the same thing. On the top is how many kings we have, which are 4 kings. And on the bottom will be how many cards in total we have, which is 52 cards. Okay, so this one, again, if you reduce the fraction, you will have 1 over 4 as well. Okay, so both events are independent. And then over here they said, what is the probability A and B? Which means, what's the probability of the first time draw a card? This is equals to the probability of first time draw. First card is an ace, and the second card is a king. What is the probability of the same happening at the same time? So over here, to calculate that, we have a formula. It's called the multiplication rule. We just need to multiply these 2 probability we find together to get that. So over here we have 1 over 4 times 1 over 4. 1 over 4 times 1 over 4. Okay. So over here we have 1 over 16 as our answer. So this probability, you can also lay out all the outcomes. So for example, you can say, you can lay out the outcome A, ace, ace, ace 2, ace 3, whatever, like you can lay out all the outcomes, you will see that eventually the number is the same. However, if you can imagine all the outcomes, there will be a lot of combinations in 52 cards. That's why we do not like to lay out the outcomes, get the probability. Instead, we use a multiplication rule. That will make your life so much easier. Okay, so this is the situation when the two events are independent. We just need to simply multiply their probability together to get this probability A and B. So the keywords over here to be please be careful is and. If the word here is or, that will be it's a very different situation. Okay. All right, let's look at example 2. Example 2 is the whole same situation. The only thing different is over here. This time, every time you draw a card, it's not replaced anymore, which means you draw a card and then you don't put it back and you gotta draw again. So you can imagine, first time we draw, there are 52 cards in total, and since you lose a card after the first draw, the second time will be only have 51 cards. So again, we're gonna define event A and B as this as well, and then they ask you, is event A and B independent? So over here, I will say it's not independent because the first, they can be influenced each other. They are the first time affects second time. Again, if you think about it, for first time, if you draw ace out, then the second time you are not as likely to get an ace again because one of the ace is gone. So the second time will be affected by the first time. Okay, so let's look at the probability. Probability A, first card is the ace. So again, we need to use the fraction on the top is our desired outcome, which is to find an ace. To get an ace, there are 4 aces in a deck of cards. So on the top will be 4. On the bottom, again, total amount of card, 52. And this one is exactly the same as our last question, 1 over 12. 13. 13, yep. Wait, hold on. Okay, guys, I make a mistake here. I'm so sorry. Oh my god. 13. And 13. Okay, do I need to redo this video? I hope not. Let's just leave it at. If you find my mistake, good job, okay? Email me, I will give you extra credit on this part. So over here, I'm so sorry. Over here, we're gonna divide by 4 on the top and bottom. So you have 1 over 13, 1 over 13. So over here as well, 1 over 13. 13 times 13 is 169. Okay? All right, again, I'm sorry about the confusion. Let's keep going. So, probability of B is again 4 over 52, 4 out of 52, which is 1 over 13. Okay, awesome. So let's look at event B. Event B happened when event A already happened. The second card you draw a king. When the first card you draw ace. So in this time you will have only 51 cards left. 51 cards left in the deck. Okay, do you agree with me? You have 51 cards left in the deck. And then how many kings has left? Again, also you have 4 kings left. Because first time we get ace, we didn't get a king. So on the top, still 4. And over here, can you reduce? I don't think so. So leave your question like that. Okay? So over here, I probably should add a little bit. So event B will be second card is a king when the first card is an ace. Okay? All right. So this time the probability of A and B also we use a multiplication rule. We multiply them together. The only thing is event A still event A, but the second part will be B happening when A happened already. So just multiply these two numbers together. 1 over 13 and times 4 over 51. Okay, on the top will be 4, on the bottom, let's use the calculator. 13 times 51 is 663. Okay, so over here, that's how you get your probability. So give you a summary here. In this point, you should be able to figure out what is independent, what is dependent, and how to determine if two events are independent or dependent. Also, you need to know how to use the calculation, how to use the multiplication rule to calculate the event A and B. So for the situation they are independent, you just need to simply multiply these two probability together. If two events are dependent, you're gonna use the probability of the first event, multiply the probability of second event when the first event already happened. Okay. Oh, I understand you might have a little confusing point over here and there. So I have 4 practice problem for you. We can work together. So let's do that. Okay. Practice problem 1. Over here, I want you to determine if the following event is independent or dependent, then calculate the probability. 1, find the probability that will roll a 6 and then roll a 5 when you roll a dice twice. So event A we will have is first time is roll a 6. Okay? And event B will be roll a 5. Think about it. If you roll a dice twice, does the 2-time influence or affect each other? Actually, they don't, because no matter how you roll, the dice is just a dice, and the probability of appearing each side is 1 out of 6, no matter what. So they are not influence each other. We will see event A and B is independent. And then the probability of event A is, let me put it on the top. So probability of event A is roll a 6, which is equals to roll a 6. 6 is 1 of the side, and total we have 6 side is 1 out of 6. And roll a 5 is the same thing. 5 is 1 of the side, so it's 1 over, there are how many sides? 6 sides, 1 over 6 again. Okay, all right, so the probability A and B we find, so we're gonna find the probability A and B. Use the multiplication rule, is equals to probability of A multiply probability of B. Let's just use star. Multiply probability of B, which is 1/6 times 1/6 equals to, all right, 1/6 times 1/6. Let me just copy it. I don't know if it's faster or not. Okay, 1/6 times 1/6 is 1 out of 36. Okay, so this is your probability. Probability of A and B happen is 1 out of 36. Let's look at example 2. A bag contains 2 red marbles, 5 yellow marbles, and 7 orange marbles. 2 marbles are drawn randomly from the bag, not replaced. You're gonna draw 2 marbles without placement. Find the probability that both marbles are yellow. So our probability of A is first marble is yellow. And our probability, event B is second marble is yellow. Okay? And are they independent? Think about the first marble you draw is yellow. Then there is one yellow marble less in the back, and the total marble amount will be less also. So the second marble is yellow, then you don't have as much as yellow marble anymore. So of course A and B is not independent, it's dependent. So the key word, as you can see, is here. So two marbles are joined, is replaced or not replaced. If it's not replaced, then the two events must influence each other. If they are replaced, then the two events are independent. So over here I have event A and B is dependent. And we want to find out the probability of A and B. Again, I'm gonna just copy that. We're gonna use the multiplication rule. It's the probability of A times the probability of B. Over here, actually, we said they are dependent, so we need to find the probability B when A is happening. So over here, actually, we're gonna use a notation. It's called B when A happen. We usually use a line in between of them. I cannot find a line. Okay, that will be a problem. Okay, let me see if I can. Oh, here we go. Okay, we use a line in the middle and put A on the side. Let me reset. Okay, so this sign means given, and we will cover it more in 12.8, I believe. So over here, I won't say too much about this given, but this is actually the formula for A and B. Over here is probability of A times probability of B when A is happening. All right, so let's look at those probabilities. What are they? So probability of A is the first marble is yellow. In the fraction, on the top will be how many yellow you have, which is, they said, 5 yellow marbles. On the bottom will be how many marbles you have in total, will be 2 plus 5 plus 7, which is 14 marbles. 5 out of 14, we got our probability. Second one, we're gonna find the probability of B when A already happened. So when A already happened, the total amount of marble reduced to 13 marbles. On the top will be how many yellow marbles have left. Since you already got a marble out, so you only have 4 marbles left in your bag. So your probability is 4 over 13. So we plug both of them into this into the multiplication rule formula to find the probability of A and B. So over here, probability of A is 5 out of 14. 5 out of 14 times multiply by second part, 4 out of 13. Okay, and on the top you have 5 times 4 is 20. On the bottom, 14 times 13. Let me use the help of the calculator. Times, yeah, probably 182. Let's reduce the fraction. Oops. Okay. Come on. 182. Let's reduce the fraction. So let's try to divide it by 2 on the top and bottom. Top will be 10. Bottom will be 91. Are we done? I think so. So we cannot reduce anymore. This is our answer. So we got our answer 10 over 91. Okay. All right, I will just gonna quickly finish the last 2 questions. If you have any question for me, please send me an email, or if you don't have any question, you can go ahead, try 3 and 4 and check answer with me. Okay. All right. So let's keep going. So George has 2 red socks, 4 black socks, and 2 white socks in the drawer. What's the probability of picking a red sock and a white sock in the order if the first sock is replaced? If it's replaced, we said it will be independent event. So again, let me write it down all the event, define the event. Event A will be picking a red sock. Event B will be picking a white sock. Okay, and then we said they are independent because there is a replacement and each time does not influence the other time. Are independent. And then we want to find the probability of A and B. Again, we're gonna use this formula. All right, calculate the probability of A on the top. Okay. On the top will be the number of right sock, which is 2 right sock. On the bottom will be total sock number. So 2 plus 4 is 6, plus another 2 is 8. 8, 2 over 8, 2 out of 8, which is 1 out of 4. Okay, and event B, picking a white socks with replacement. So over here, the total socks number is still 8. And because the first time you pick the red sock, already put it back. So 8 socks on the bottom. On the top will be how many white socks? Will be 2. Again, your number is 1 over 4. Reduce the fraction. Okay, and multiply these two numbers together. 1 out of 4 times 1 out of 4 is 1 out of 16 times is 1 out of 16. Oops. Okay, that is question number 3. Number 4, I'm just gonna go ahead, finish it up very quick. The rest of the worksheet about Venn diagram, I will introduce in another video. So over here, I just gonna copy down everything, the format I have, so I do not need to type it all over again, and we're gonna change the event. This question is saying a card is drawn from a standard deck of playing card. It is not replaced. When you say it's not replaced, it has to be dependent event. Then the second card is drawing. Find each probability. The probability we find is Jack of Spades and a black card. So the first event is we're gonna pick a Jack of Spades first. Jack of Spades. And the second event, we're gonna pick a black card. This question is quite interesting, I will say. All right, let's do this. So the first event, hold on, let me change this. The first event is picking a Jack of Spades. Let's go to our deck of cards again. Where is Jack of Spades? So we're gonna find spade, this color Jack. This is Jack of Spades. In every deck of cards, we only have one Jack of Spades. So on the top we have should be 1. Okay, let me erase all of this. And event A's fraction will be 1 out of how many cards we have? 52 cards we have. Okay, and event B, there's no replacement, which means the Jack of Spades already gone. So let's look at this. Probability of B is equals to getting a black card. Let's look at how many black cards you have. You have 2 suits of black card, and each suit is 13 cards. So in total, you will have 26 black cards. However, your Jack of Spades is gone. So over here, you only have 26 minus 1, which is 25 black cards left since your Jack of Spades already gone. And then on the bottom will be your total card number in deck right now. If you take a Jack of Spades out, you only have 51 instead of 52 cards in the deck. So over here we go. We find our 2 probability, and we just need to find the probability of and using the multiplication rule. So what we're gonna do is we're gonna multiply these 2 together. Alright, it will be a struggle. And also another struggle will be when we multiply them together because it's a big number, but it's okay. We got this. And equals to multiply a fraction. You're gonna multiply the numerator together first, 25, and then you're gonna deal with your denominator, 52 times 51. Okay, I'm not using mental math. I'm just playing some magic on my calculator here. 2652. So 25 out of 2652 is our final answer. There's nothing to reduce, so I will just leave it here. All right. Okay, so this is today's lesson about multiplication rule, and obviously my camera does not want to cooperate with me right now. All right, let's see if that works. I don't know if it will ever work. But anyway, this is our lesson for multiplication rule. I'm back. All right, so this is our lesson for multiplication rule. I hope you learned something from it, and please finish your ethics assignment. And there's another question about Venn diagram, which is your last question in this assignment. I will upload another video later today or tomorrow to help you figure out how to read a Venn diagram and how does multiplication rule apply in the Venn diagram. Okay, so thank you for watching my video, and it's my pleasure to still teaching you, and like you are still learning in this hard time. And okay, I'm already start to talk too much. But anyway, I will see you next time. Okay, bye bye. Heart. Okay, did you see my heart? Yep, here's my heart. Bye bye.